potatoes with built-in insecticide, rice with extra vitamin A, decaf coffee beans fresh off the tree. Just when Americans have begun to digest the idea of custom-built crops, along comes another major advance in biotechnology that could make an even bigger splash onto the dinner plate: genetically engineered animals.
There's many definitions, but I think probably a working definition would be an animal that has a gene introduced conferring a specific trait that would not have been available in that animal without having come from another genetic source. And this could be used to improve the production of a product the animal already produces, whether it be, for example, lower interstitial fat. It could be used to turn off the production of something, for example, turning off or turning down beta lactose or lactose production in milk for those that are intolerant, for example. Or it could be used to produce an entirely new product, for example, the production of pharmaceuticals in animal milk, and that's the one where the big money is.
Defining a transgenic animal is a bit difficult because we have been using selective breeding for centuries. And this is taking animals, cows, chickens, doesn't matter, and mating and then selecting for certain characteristics. In the case of chickens, larger eggs, they have more yolk, a variety of characteristics. What we've been able to do in the last 30 years is very selectively and very precisely transfer the genes into one strain of animal to another. And rather than the rather imprecise, but it was effective, imprecise breeding, crossing, selecting. Now we're able to do this by taking specific genes that have been identified that are responsible for, let's say, the coat color, for the height, for the size of the egg, etc., and being able to transfer those genes from one animal species to another.
Transgenic animals are just another class of products developed through biotechnology that, it is hoped, will give renewed energy to the decades-old green revolution. Transgenic technology promises more and better crops and food animals to feed a continuously growing world population.
Since 1900, we've gone from 1-point-some billion people to 6 billion, and by 2030 to 10 billion. Obviously, we've got to find a way to feed the populations of the world. And in fact, at the same time, the arable land, the tillable land, has decreased significantly, maybe by half, just in the United States alone. So it's less land, has to be more productive. We can't afford loss of wheat or corn to insects, to rusts and mold and so forth.
We do face issues in terms of feeding human population, and as it grows in the next 30 to 40 years, the estimates are that we will at the very least have to double or perhaps even triple the total amount of goods that are produced for people to eat. And that presents a lot of difficulties. We certainly don't want to use up every bit of arable land that we have, and we certainly don't want to continually increase the amount of fish that we catch in the ocean. None of this is sustainable. All of it comes at the cost of biodiversity. And we also don't want to use up all the available coastal space for aquaculture purposes either. So the real objective of a lot of agricultural biotechnology is to enhance productivity so that we can do more with less. And that's really the goal, and I think that that's an admirable goal.
Genetically engineered plant crops, such as corn and soybeans, have been on the market for several years. Now, genetically engineered animals may soon begin to make their way through the regulatory net and ultimately to the dinner table, possibly starting with fast-growing fish that the sponsor promises will begin a blue revolution. The potential benefits of transgenic animals, however, do not stop at food production. Scientists created the first transgenic animals to advance basic biomedical research, genetically modifying lab rats, mice, rabbits, and monkeys to give them characteristics that mimic human diseases. These research resources, for example, rapidly advanced the understanding of oncogenes, genes that go awry and are responsible for causing cancer. Moreover, researchers now seek ways to genetically modify the organs of animals, such as pigs, for possible transplantation into humans. And finally, transgenics can turn animals, such as cows, sheep, and goats, into pharmaceutical factories that produce in their milk protein-based drugs such as alpha antitrypsin, a protein that can be used to treat cystic fibrosis.
Because the biggest money, of course, is in the whole medical area and pharmaceutical production area, you will see over the next while the greatest focus of technology is going to be on developing systems for more efficient production of pharmaceuticals in milk, blood, or indeed in urine. And one really interesting company are producing it in pig sperm, which is a very good media, actually, produce lots of it for high-level production of valuable products. I think the technology that's been evolved to actually produce from pharmaceuticals can then be co-opted by those that are interested in the agricultural end of transgenic animal production to improve meat characteristics or milk to make it less allergenic, to improve the healthfulness of milk, for example, to reduce the fat, that type of thing.
Despite these benefits, genetic engineering of animals has met with some of the same resistance already aimed at designer crops. Critics cite ecological concerns, ethical objections, and food safety issues.
There's a whole host of concerns with transgenic organisms, plants, animals, whatever. One of the concerns that environmentalists raise deals with the release of those organisms into the environment. Is that what you've done is you've created a completely new organism with completely different characteristics than the naturally occurring organism. And when put into an ecosystem, we have very little to no ability to predict what will happen when that organism goes into the ecosystem.
If anybody here is asking for something that's foolproof, then I suggest that they not get out of bed in the morning and they start hiding, because nothing in life is foolproof. What we do is we try and always reduce the risks and measure them against the benefits. And if the benefits outweigh to a great degree the presumed risks after the risks are minimized, then as a human species, we proceed. If you don't take risks, you make no gains. And don't ever forget, as they say in the ads, the greatest risk is not taking a risk.
No matter how transgenics is applied, the Food and Drug Administration will play a key role in regulating the products resulting from this rapidly emerging genetic technology. This means that any drug or biologic created through transgenic techniques will need to undergo the same FDA scrutiny as any other treatment that a company wants to market, including clinical trials that demonstrate safety and effectiveness. While it's still too soon to tell how quickly foods derived from transgenic animals will move to the market, the FDA has already begun to focus on how it will ensure that they meet the same safety standards as traditional foods.
There are many concerns, largely because the public is not sufficiently aware of the scientific advances and what science is bringing in terms of benefits in this area. So it's important for these scientists to unite and identify where there may be gaps in scientific knowledge, what risks there are, if any, and to engage effectively in a public dialogue with other stakeholders so that some of the fears, which are totally unjustified, will be dissipated. At the same time, some of the concerns, if there are legitimate concerns, will be identified, and there will be action taken to address those particular concerns.
I think the first genetic engineering was done in 1970, so we have about 30 years of experience, and we do not have an example, a set of data that shows an adverse effect in that 30-year period, which is remarkable, truly remarkable.
So we have to start with the safety. That's the first point. If we don't have the safety, we might as well leave the products in the lab. We don't want them in the society. But then society is saying, I want to know more about it. I want to make sure that, in fact, it's okay for the environment. I want to make sure that it's okay for, the people that are raising it. I want to make sure the farmers are benefiting from it. There's a lot of other issues, and it just comes down to, I think, a basic weighing of, are the goods much better than the bads? Because you're never going to have 100% good or 100% bad.
It's very important that the public not be frightened, that they know that there is a regulatory framework that is addressing these issues, that this is not a question of mad scientists hiding in a basement about to spring something on the world that will bring on a worldwide epidemic. I mean, it's very important that the public fully understand what is going on.
Making a transgenic animal is deceptively simple, especially when compared to traditional breeding approaches. In traditional breeding, when farmers or breeders want to introduce some new characteristic into a type of animal, they must find an individual animal that carries the desired trait. They then mate the individual to try to create a new line of animals sharing the genes that express the desired quality. With genetic engineering, however, scientists possess the tools to isolate and manipulate single genes in the laboratory. In recent years, researchers have learned to insert single genes into the fertilized eggs of animals in such a way that the new gene is turned on in the resulting adult. First of all, the scientist isolates the gene that conveys a particular trait of interest, disease resistance or faster growth, for example. Then a molecular vehicle is created that will carry the gene into the nucleus of the cell and permanently integrate it into the chromosome. The entire construct, the transplanted gene called a transgene, and its transport vehicle might be physically injected into a fertilized egg using a glass needle viewed under a microscope. Other approaches use disabled viruses to inject the construct into the cell. If the egg survives and begins to grow and divide, then the potential embryo is implanted into a surrogate mother. Of the offspring that make it to birth, only a very small number will carry the gene integrated in such a way that it actually functions. But when it does work, the result is a new individual of a variety of animal with a characteristic never before seen. The individual animal can then be multiplied by conventional breeding. The resulting animal may be enormously valuable. Inserting a single gene into an animal that then manufactures a rare protein in its milk could produce a drug that is worth many millions of dollars an ounce. The Genzyme Transgenics Corporation of Cambridge, Massachusetts, for example, has created a goat that carries the gene for antithrombin 3, a blood protein that can prevent blood clotting in people. The company purifies the protein out of the goat's milk.
I mean, there are other concerns associated with organisms as well that are producing proteins that are of pharmaceutical or industrial interest. Some of the concerns that we've raised have been what happens to the waste from those organisms, because in fact, you have now new byproducts of waste. that waste is no longer simply goat manure. It's goat manure with some kind of pharmaceutical added to it. And to give an indication of that these are not just goats, at the end of their life, they have to be incinerated. They're not buried, right? They have to be incinerated. And much care has to be made to make sure that they're not going into the food supply. When we start talking about huge numbers of these animals being grown to produce these particular proteins, that magnifies those concerns over, incineration, over their waste, over worries that there's going to be some mistake and something's going to go into the food supply.
But even though the medical applications of transgenics remain intriguing, the animal health and food production applications seem to be generating most of the new excitement and considerable concern. Taking their lead from the scientists who created new genetically engineered crops that, for example, resist insects without the need for pesticide spraying, researchers involved in the production of food animals began to think about how they could use genetic modifications to improve the production or the quality of their products. The best example so far of the transgenic strategy in food animals and its success is the faster growing salmon. The science behind the so-called super salmon was discovered by accident over 20 years ago, when Choi Hugh, then a researcher at Memorial University in Newfoundland in Canada, accidentally froze a tank filled with a particular species of flounder. When the tank was thawed out, the flounder were still alive. Initially, no one knew how they survived. This species, it turns out, has a gene that produces a protein that works like an antifreeze in a car's radiator. Researchers isolated and copied the part of the flounder DNA that works like the genetic switch to turn on the production of the antifreeze protein. Normally, this genetic switch is only turned on when the fish is exposed to cold. Hugh and his colleagues then attached the flounder's genetic on switch to a previously isolated gene from Chinook salmon that produces a growth-stimulating hormone. Using transgenic techniques, they inserted the new combination, the flounder on switch, with the salmon growth hormone gene into fertilized salmon eggs. In the resulting salmon, the flounder's genetic switch appears to stay turned on, producing a continuous supply of salmon growth hormone that then accelerates the fish's development.
In the case of Aqua Bounty Farms, the creation of our what we call our Aqua Advantage salmon is really done by splicing together a portion of a gene from an ocean pout, which is an edible fish found in the North Atlantic, to the salmon's own growth hormone gene. Now, it's that combination which is really of interest to us, because what this allows the salmon to do is utilize its own growth hormone more efficiently than would otherwise be the case. That's really the only change which has occurred in our fish. It's a single gene change. It's relatively minor in that respect, but it has the interesting consequence that the fish grow much faster because of that enhanced utilization of the protein produced by the gene.
While the resulting fish do not seem to reach a mature size that is larger than conventional salmon, they do grow much faster.
A common misconception has been that the fish might grow bigger, but after 12 years of experience, we can say that in the case of Atlantic salmon, these fish simply do not grow bigger. They simply get to their full adult size in roughly half the time than they otherwise would. And this promises a number of advantages, including particularly some environmental advantages as well as some commercial advantages. The commercial advantages are fairly obvious and fairly clear. If you can produce something in half the time and it costs less, then that will give a broader range of consumers the ability to afford it. It will be cheaper. At the same time, it can enhance business as well, because you can be more profitable, obviously.
Breeding transgenic varieties is an effective way to create an animal with a new characteristic, but large mammals, cows, pigs, and goats, don't multiply as plentifully or as rapidly as fish. Several research teams have turned to cloning, as in Dolly the sheep, as a way to expand the herd of transgenic animals. This approach combines two cutting-edge techniques. First, a transgenic animal with the desired characteristics is created. Then, cloning techniques are used to create replicas of the transgenic animal. Using a transgenic approach just makes it easier to get the genetic characteristics in the animal that is desired, which is then cloned to produce a core breeding herd.
The work on pharmaceutical production in milk is primarily really in the US and in Japan actually as well. The cloning technology in animals, which again is really being used to increase the herd size of animals carrying specific genes, because hopefully it will be in the future a more efficient system to ensure consistency in the expression of specific genes, and that would again be focusing on the pharmaceutical side. That really is primarily in the US now, although there have been some success stories in Japan and Hawaii, and Hawaii of course is part of the US. And even though Dolly was initially produced by Ian Wilmot in Scotland, there really isn't that big a focus in the UK, primarily because of funding.
The area of animal or transgenic animals actually opens up a new area for regulation that had not been anticipated before, because when you release organisms into the environment, this matter of regulation falls to the jurisdiction of those entities in government that are responsible for environmental protection. Most of the safety regulations in the past has been controlled by institutions that really don't deal very much with the environment. So what I think is likely to happen is that we're going to see environmental ministries or departments playing a larger regulatory role in partnership with other institutions than we have seen in the past.
Useful as it may be, animal biotechnology won't go forward without objections. For all the promise that industry sees in the dawning era of genetically engineered animals, others, including animal rights activists, environmentalists, and consumers, see considerable problems.
There are also food safety issues associated with genetically engineered organisms. When you're taking that genetic information from one organism and putting it into another organism, you're moving the capability to make a particular protein. That novel protein may or may not have ever been part of the human diet. Moreover, organisms are extremely complex, and it's very simplistic and not a correct assumption to think that all you're doing is moving a single protein, because the protein in the cell has multiple interactions. The protein in the larger physiological body of the organism also can have multiple interactions.
The issue of some scientists saying that these fish could pose health issues to human beings or allergenicity issues to human beings, I truly believe is made up by the pressure groups that have posted that kind of information. I am not aware of any credible biologist who has come out and suggested that the genetic alteration which we have done in those salmon would necessarily or even likely create any kind of a human health hazard. Nevertheless, that's precisely what we have to demonstrate to the FDA, because once again, nobody, including ourselves, are going to just simply take anecdotal measures or anecdotal research for this as an answer. Instead, we have to prove by the traditional scientific methods what will be the result in human health. The history of genetically modified organisms, genetically modified agricultural organisms, to date has been uniformly that they've been safe. There's not one single case of even a stomach ache having resulted from the genetic modifications which have occurred.
The concern about genetically engineered foods, says various scientists from Greenpeace, is in marked contrast to the public acceptance of genetically engineered drugs. When faced with serious illness, most people are willing to take risks to combat a disease. Food is different since it is so basic both physically and emotionally. it is not surprising that consumers are extremely averse to any food-related risk, especially if the risk is perceived as imposed by someone else, beyond individual control and without any countervailing benefit.
I think what we're seeing is that when we have anything that's new, one of the lessons we've learned from studying history in this area is anytime there's a new food technology, we can go back to pasteurization. That was very controversial. That took 50 years before society accepted pasteurization of milk. And in fact, they still don't accept it in some parts of Europe. Europe still prefers unpasteurized cheese.
And that's a very classic sort of U.S. Philosophical basis, that risk is an individual kind of thing, and we as individuals, we accept risk every day, and shouldn't we also accept these risks? But what they're asking us to do is accept, as society generally accepting risks, but the benefits are going to the biotechnology companies, not necessarily to the broader society. So that when you ask questions of risk and benefit, you also have to ask the question of who risks and who benefits. Now also, in terms of individuals accepting risk, so that's the argument, that an individual accepts the risk of a cell phone or getting in a car or getting on a plane. In the United States, we're not given the choice of whether to accept the risk of genetically engineered organisms or not. They're not labeled. In the European Union, they are labeled. People are given a choice, and they're overwhelmingly saying, no, we don't want genetically engineered organisms. We don't want to accept that risk. So once you allow people to make that distinction, to decide whether or not to take this risk, in Europe they say no. In the United States, unfortunately, we haven't been given that choice yet.
There's a major global debate taking place on the environmental consequences of introducing genetically modified organisms into the environment. And one of the main concerns that has been expressed by the public is whether these organisms have a negative impact on the environment or not.
Some groups, supposedly wedded to the good of the environment, have fastened upon biotechnology as a bogeyman, as something that can be attacked, raising the fears of people, and on the side, raising more money for their coffers. One can't overlook that.
Show me any food we eat is safe. It's been over years of empirical data that we've managed to produce a pretty good food supply. But the greater concern, as far as I'm concerned, is contamination. Bacterial pesticide contamination is far, far greater concern if you're going to put it in context.
People who like fresh caught fish may not want to consume that fish, even if it's a non-genetically modified. They may say, I don't want pen-raised fish. I don't want something that's grown on a fish farm. Does that mean it's not safe? Does that mean it's different? No, it just means there's a preference that some consumers may have that says, I want the quote-unquote natural, variety. But the problem is you can't go out and catch enough salmon to meet the demand anymore. You can't catch enough fish. And so what are we going to do? Pay $50 a pound, not eat it, or have some of these kind of fish. And I think each one will be evaluated carefully on a case-by-case basis.
The FDA commissioner, however, points out that foods produced using bioengineering processes are evaluated to make sure they are not more likely to cause allergies. It is not just about dangerous foods, it's also a matter of consumer choice. Then there are environmental concerns. Purdue University animal scientist Bill Muir and biologist Rick Howard conducted a study funded by the USDA on genetically engineered fish, which led them to warn of possible risks from transgenic fish escaping into nature.
There are people with financial interest in transgenic animals that would argue that the risk to the environment is minimal. Unfortunately, I don't think that that's the case, and we have a long history, for instance, in salmon farming, of escapes. And in fact, just in December of last year, a salmon farm in Maine, there was an escape of over 100,000 salmon from that farm. Now that's just farm salmon. Those aren't transgenic salmon, but you can understand what the magnitude of those escapes mean. If they were transgenic salmon, the impacts would be magnified because the transgenic salmon grow bigger. Compare that 100,000 escaped salmon with the number of returning salmon that we have in some of our endangered salmon streams. One of the rivers had last year 5 native salmon returning. And so it's very clear that farmed salmon can overwhelm native salmon populations. Farmed salmon that are transgenic and that grow even bigger than regular salmon are going to be an even bigger problem.
So in this case, what we've done is we've taken a look at our product, and we've said that today, salmon farmers are growing fertile fish which do escape in large numbers, which do interbreed with the wild fish, and which environmentalists say is detrimental to the wild population. We come along and we say, you know what we want to do is we want to produce a sterile fish and substitute that for the present fertile fish. And we want to produce an all-female fish, which will even have less chance of mating with the wild cohorts. And what is safer? What is occurring today or what we propose to substitute? We believe very firmly that what we propose to substitute is safer, but we don't expect anybody to take our word for it. That's where the independent studies come in. It's not up to me to refute what Bill Muir says or what Purdue analysts have decided may or may not be true. That's up to groups of scientists who will be taking independent looks at this, examining the situation, and coming to conclusions. And we will abide by those conclusions.
Greenpeace's position is that transgenic organisms should not go into the environment, that the environmental risks associated with the release of any transgenic organism, microorganism, plant, animal, those risks are too great. Genetic manipulation is a science in its infancy, and we know very little about the risks to the organisms or to the environment when we put those organisms in the environment. And our position is against the release into the environment of genetically engineered organisms and the release into the human food supply.
They worry that transgenic fish escaping from aquaculture facilities into the wild, for example, could damage native populations, even to the point of extinction.
Well, the risks have to be weighed and measured, but they should be done so on a scientific basis and not through a public hysteria generated by misinformation and exaggeration from opponents.
I believe that the debate has actually generated considerable interest in environmental research to levels that we hadn't anticipated in the past. So one of my expectations is that we're going to see a renaissance in the area of ecological studies as a consequence of the debate that's taking place at the moment. And the challenge is whether governments particularly will recognize this early enough and start funding research in these areas. For example, most people who are concerned would like to know what the exact impacts are likely to be. But you cannot assess the impacts unless you have baseline information. And right now, baseline studies are extremely few and scattered. So I expect that we're going to start seeing serious investment in providing information that basically establishes the ecological baseline against which you can assess the consequences of the introduction of new organisms into the environment.
The way I look at this is sound scientific research on the safety of these foods would be considered a necessary but not necessarily sufficient condition for public acceptance or for societal acceptance. Because we have to go beyond just whether it's safe or not. We have to say, is it beneficial or not? Is it good or not?
At a time when genetically engineered plant crops have spurred protests in the United States, the use of biotechnology in food animal production is likely to attract an even larger set of critics because both transgenics and cloning deal with animals. People for the Ethical Treatment of Animals and Greenpeace, large animal rights organizations, for example, feels that people shouldn't be tinkering with animals like Frankenstein and is very much opposed to intensive animal agriculture. The FDA already has the legal authority to regulate most products derived from transgenic animals, whether they are used as drugs, as human food, or as animal feed. Therefore, only guidances or regulations that cover specific aspects of animal biotechnology may need to be added, not whole new statutory frameworks for regulating the products. These guidances will likely address such issues as safety of the target animal and protection of the environment. Most of the gene-based modifications of animals for food production fall under the FDA regulation as new animal drugs. The genetically modified growth hormone for the fish, for example, will be regulated the same way the agency regulates bovine somatotropin, the genetically engineered bovine growth hormone that makes cows produce more milk. Transgenics simply provides another means to add growth hormone to an animal. With transgenic salmon, the inserted growth hormone trait is inherited by subsequent generations. With cows, the drug is periodically injected into each one. Either way, products regulated as new animal drugs in the United States are subject to rigorous pre-market requirements to determine effectiveness and ensure food, animal, and environmental safety.
You know, salmon is only one very small part of a web of aquaculture products which really are grown in all parts of the planet. So we've begun with salmon, but we've also worked with trout. We're working with flounder, with a freshwater fish called tilapia, which is among the world's most commonly grown fish. We're interested in taking a look at carp. We're interested in, as I suggested before, applying the lessons of biotechnology to fish growth, period, and to fish health. Those are the issues, and so really we see the company as continuing on this path and expanding its operations to include some of these other species.
And if there's a compelling benefit, as you mentioned with the salmon, most of us are being told we should eat more fish, we should eat more, and we don't like to pay necessarily $10, $12 a pound for the seafood. If there's a compelling benefit, like more readily available, safe and wholesome seafood at a much cheaper price, I think we have to weigh that into the equation. First of all, as I said, we've got to make sure the products are safe. That's why we have the FDA. That's why we have a very, I think, strong regulatory program in this country, more so than in Europe. Europe's now trying to formulate a regulatory program that's as credible and as effective.
One of the good things about regulating transgenics as animal drugs is that scientists can make sure that the environmental controls and other safety measures are built right into the process. This process includes target animal safety, safety to the environment, and safety for consumers to eat foods derived from genetically engineered animals. The FDA intends to use various approaches, including a contract with the National Academy of Sciences, to identify further environmental safety issues associated with investigation and commercial use of transgenic animals. To do this, the agency will cooperate closely with other federal and state agencies that have related authorities, such as the Fish and Wildlife Service and the National Marine Fisheries Service in the case of transgenic Atlantic salmon.
We don't hear nearly the same kind of questions being raised about medical research, medical biotechnology. I'd say at least yet. I think as we get into some of the genomics areas and the understanding of human genetics, I think we'll start seeing questions arise there as well. And I think that's good. I think the more questions we ask, the better we're going to likely find the answers to be. I think that's the key, is that we look at each one of these and carefully examine them.
The Food and Drug Administration already are gearing up for the major debates it expects regarding transgenic animals. debates likely to mirror the discussions now underway for bioengineered crops. At this time, no transgenic animals have been approved to enter the human food supply, but a few individual transgenic animals have been allowed to be rendered and used in animal feed. While it's true that new compounds to combat specific diseases or to optimize the nutritional value of food products can also be created by conventional means, researchers believe that transgenics technology can help make it possible to produce them more quickly, in larger quantities, and ultimately at lower cost to consumers.
There's research on genetic modification or advanced hybridization of fish that's occurring literally in all of the major fish-producing countries of the world, certainly across Asia, in Europe to a lesser degree, in other laboratories in the United States, Canada, South America. I believe at last count there's somewhere in the order of 40 or so laboratories around the world that are currently working on one aspect or another of modifying fish so that they would be more productive in terms of their commercial attributes.
Some countries may be interested in expanding production, others may be interested in controlling disease. Others may be interested in maintaining consistency in the breeding lines. I think it offers tremendous possibilities for partnerships between the industrialized countries and the developing countries. Chances are that, in fact, developing countries have their own priorities, and they'll do that in partnership with colleagues in the industrialized countries.
With food, it's a very sensitive issue. So I think in many ways that's why this issue is so complicated, because it doesn't come down to science. It doesn't come down to safety. It comes down to culture. It comes down to values. It comes down to a whole host of things that scientists often aren't able to address. I'm not trying to say none of these concerns were valid. I think they were all just an example of how anything takes time for people in society to understand it, to become comfortable with it. So I think the initial reaction we're seeing to biotech foods is quite understandable. I think it's a normal reaction to something new, and particularly when we deal with food, which in and of itself is a very emotional subject.
Beyond regulatory issues, beyond scientific issues, the real issue is people getting comfortable with this kind of technology. You know, as human beings, we're always a little bit slow to adapt. Nobody likes too much change too quickly. And I think that in part that does occur, and that has occurred in the last couple of decades. You know, it was bad enough that we had the computer revolution in the last 20 years. Now they're playing with my food. I mean, you know, there's a lot of things that are happening very quickly around the world, and we need to get used to it. You know, interestingly, just to remind you, when Thomas Edison first came up with the idea for the commercial production of electricity, no city in the United States would accept it for a period of over 7 years. The danger was thought to be that if you turned on a light bulb, you would get electrocuted. The result of that was that it took the same kind of education, it took the same kind of slow internalization by people to make the realization that this was something which provided benefits, which was something that could be used safely. And we face the same problem. I mean, those of us who are involved with genetic modification today can point out all we want that we've been modifying foods genetically for 10,000 years, which is totally true. But if you give it a different label and you apply modern science, it seems to change it more perhaps than it really is being changed. And we need to get people comfortable with it.
I think in that area, the best way to look at it is to use the technology to solve specific problems. For example, areas where they have got livestock diseases, to use the technology to solve those technical problems, not necessarily to expand production. Some countries may be interested in expanding production, others may be interested in controlling disease, others may be interested in maintaining consistency in the breeding lines, so they may go into cloning, for example. And so if you think of it in terms of being able to use the emerging techniques in animal biotechnology to solve specific problems in the developing countries, I think it offers tremendous possibilities for partnerships between the industrialized countries and the developing countries. Chances are that, in fact, developing countries have their own priorities, their own animals that they would like to improve upon. and they will do that in partnership with colleagues in the industrialized countries.
Well, I think certainly what we're going to see in the area of transgenics more generally is that we're going to see a lot more products that have a tangible benefit to a consumer. Many of these early products were mainly beneficial to the farmer. You know, would allow them to raise their animals more quickly, would allow them to raise animals or raise crops that were maybe more protected from disease or insects and things like that. What we're going to see in the near future are some products coming through the pipeline that have a very tangible consumer benefit. And while some of these benefits to consumers would be healthier foods that would contain lower levels of saturated fat. For example, we could see transgenic animals that produce very lean meat that still tastes good. Possibly we're going to have soybeans that are going to have higher levels of antioxidants in them. We're going to have things that are just more healthy in terms of our food. But I think the real virtue will be as if somehow we can produce food that tastes good and it's still healthy for us.
So many new discoveries take place, so many new applications take place. But my own feeling about it is it's one of the most exciting technologies that we have at the moment in front of the scientific community and in front of our civilization. I think there is the potential here for feeding the world in a way that the world has never been fed before.
After 10 years of examining products on a case-by-case basis, the FDA officials say that the guidance and regulatory structure for animal biotechnology is starting to evolve, and it is hoped that everyone can learn from our experiences with plant biotechnologies that would make the road a little smoother with regards to animal transgenics.